Hey everybody, today we're solving LeetCode 67, which is called add binary. The question asks, given two binary strings A and B, return their sum as a binary string. We'll go over a couple of different ways to solve this today, and we'll go ahead and get started with method 1. Our binary strings are A and B respectively of 1010 and 1011. Underneath each of these two binary strings, I just have the bit place values. Our first step for this method is going to be to first convert these numbers to decimal and take the sum. So 1010 is just representing the decimal number of 10. If we just take the sum of all these positions, we'll take the 8 plus the 2, and then the 4 and 1 have 0, so we don't use any value from that. 8 plus 2 is 10, and then for 1011, we take 8 plus 2 plus 1, and that's representing 11. 10 plus 11 is 21. Now, all we need to do is convert that back to binary, and that's our final answer. So 21 represented in binary is as following. We just fill in the right bit place values of 16, 4, and 1. 16 plus 4 is 20, 20 plus 1 is 21, and our final answer is 10101. So this method works very well for smaller binary numbers, but is going to encounter precision limitations for very large binary numbers due to JavaScript's number representation, and I'm going to be using JavaScript to solve this. I actually ran this on LeetCode and it didn't pass all the test cases, so we're going to need something more compact, and that's where method 2 comes in. So for method 2, we're going to use the exact same two binary strings of 1010 and 1011. However, right here I just want to clear up that these are indexes underneath in green. That's going to be important for later, just to help us keep track of the position. I know over here I had the bit place values. This is completely different than these indexes. This is just representing the position of every element in the string. Okay, now that we have that cleared, let's look at the variables we're going to use. First of all, I want to go over the carry variable. Carry is initialized to 0, and this carry represents the value that is carried over from one digit position to the next when the sum of the current digits exceed the base of the number system. The carry is important because it affects the sum of digits at the next position. When you encounter a carry, you need to account for it in the addition of the next digit. So if the sum of two digits is 2, which is like just 1 plus 1, you write down a 0 for the current position and carry a 1 to the next position to the left. I'll demonstrate that now in case it's not clear. So I'm going to just do this exact same example, but I'll just do it directly like this. 0 plus 1 is going to be 1. That's very faint. 0 plus 1 is 1. And now we have 1 plus 1, that's 2. As I mentioned, if we have to, we can't write 2, right? Because we're only dealing with 0 and 1s in binary. So we're going to put a 0 for the current position, and we'll carry over the 1 to the left-hand side, because we work right to left with binary. I should have mentioned that. So now we have the next position, 0 plus 0, and then we also have to consider the carryover, which is 1. So 1 plus 0 is 1. And now we have 1 and 1 again, that's 2. We put a 0 in this place, and we put the carryover on the next column. And since we have no more remaining numbers here, we'll just use 0 and 0. 1 plus 0 is 1. And our final answer should be 10101. If we confirm that down here, where I actually went through the entire process, it's the same thing. So I hope that carry is now clear to you. The next thing is this result variable I've initialized, the string. And this is going to store the final binary sum that we're going to return. Our I and j are just going to be pointers that are going to help us iterate through the input string from right to left. I've initialized them as a.length minus 1, so we can start at the very end. So just keep in mind that we subtract 1 because we're using zero-based indexing when we're operating on strings and arrays and whatnot. So let's just jump right into it now with we're working right to left, so at I equals 3, at j equals 3, and so far we have a carry of 0. These are going to be the three important things we are keeping track of, because all of this is happening inside of a while loop. And our conditions are going to be, so as long as A has a length, as long as B has a length, and as long as there's carryover, we're going to be carrying out these operations. We want to make sure we're keeping track of the lengths or positions of I and j and a and b separate respectively, because these can be different lengths, right? Right now I've made them convenient that they're the same length, but if a was greater than b or if b was greater than a, would want the loop to continue while either of them still have lengths. Alright, now that we're all set, let's start off with getting our number from A and our number from B. Those are just going to be the elements at that index position of 3. So for num A we have 0, for num B we have 1. Moving on, we're going to calculate the sum. So that's going to be the sum of num A plus num B plus whatever the carry over is. Initially that's going to be set to 0 as we did, but remember from up here when we started adding them to the actual sum, we're just going to account for that from the beginning. So 0 plus 1 plus 0 is just 1, and that's going to be our sum. Now for the result string, we're going to be taking the modulo of sum modulo 2, and we're going to add the rest of the result string to the right of that. So 1 modulo 2, well 2 goes into 1 0 times because it's greater than it, so we're going to have a remainder of 1. And since we have an empty string initially, that's going to be all that's in the string. So that's the rightmost element of our final answer. Finally, we'll calculate the carryover, and that's going to be a math.floor, which just rounds it down of the sum divided by 2. Our sum was 1, so 1 over 2 is 0.5. If we round that down, it goes to 0. Okay, now we can move on to the next position. We'll decrement our pointers, I and j, so now they're the second index. Since our carry was 0, we calculated, we're going to also have that. So num A and B are 1 and 1 respectively at index 2. Our sum is going to be the sum of these num A plus num B plus the carry, and that's 2. To calculate the result variable, we're going to be taking 2 modulo 2, as this was the equation earlier, sum modulo 2 plus result. So our sum is 2, we take that modulo 2, so there's no remainder remaining, so we're going to have 0, and then we're going to be adding whatever the result string is, and we only have a 1, so that's that. And 2 modulo 2, as I mentioned, is 0, there's 0 remainder, so we just have that, and that's concatenated together. Finally, we'll calculate the carry variable, and that's the rounding down the sum over 2. The sum was 2, divide that by 2, which is 1, round 1 down is just 1. So our carryover is 1. I'll move over the next 3 pretty quickly now that we have a good grasp of this. We'll decrement the pointers. We're at index 1 now. Our num A and num B are 0 respectively. Our sum is going to be 0 plus 0, which is just num A plus num B plus the carryover. Remember, we calculated the carryover as 1, so we're going to keep track of that. Our sum is 1. Our result is just 1, the sum modulo 2, which is 1, and append that to the left of the result string. So we have 1, 0, 1 now. Our carryover is 0. You can do that on your own if you'd like using the formula. Next position, we decrement, so we're at I equals 0, j equals 0, and our carryover is 0. Positions at those index is 1. For both num A and num B, we take the sum as 1 plus 1 plus 0, because the carryover is 0. That's equal to 2. Our result is equal to 0, 1, 0 once now, and our carryover is 1. Finally, we get to the negative 1th position because we're decrementing, right? We'll have to create, as I did here, we'll have to just set these values to 0 because there is no valid value for num A or num B at that index. It doesn't exist, right? So we're going to have to take that value of 0. We'll calculate the sum as 0 plus 0 plus 1 because we had a carryover. Remember, we're operating this whole loop while either A has a length, B has a length, or we have carryover. And we've actually exhausted the lengths of A and B. There are no more elements remaining, but we still do have carryover. So this final iteration is still going to continue. So we calculate our sum. Now the result is going to be that, and it ends up just being 1, 0, 1, 0, 1. Finally, we'll calculate the carryover. That there's no carryover remaining, and we can return our final result of 1, 0, 1, 0, 1, which is the same as what I got using this method, and that is the correct answer. Here is the code to our solution. So first things first, we're going to initialize all of our variables. I've already gone through this on the whiteboard, so if there's any confusion surrounding this, please rewind the video. Next, we're going to enter our while loop that's going to continue until we've processed all digits in both input strings and there's no more carry left. We're going to obtain values for our num_a and num_b variables through this conditional operator. We're going to check if the pointer is at a valid position of greater than or equal to 0. If so, we're going to be calling parseInt on the relevant string at that index. Remember, these are binary strings that we're given. They're strings, so we're going to have to convert them to an integer before doing any sort of arithmetic on them. If the pointer isn't at a valid position, then we're going to assign it a value of 0. We'll then calculate the sum, considering all of the num_a, num_b, and the carry. We'll then calculate the result by taking the modulo sum mod 2 plus the rest of the result. We can then calculate the carry by rounding down the result of the sum divided by 2. Finally, we'll decrement the pointers I and j. Then we'll exit the loop after we've exhausted all the string lengths and carryovers, and we'll finally return the result. If I run this, should pass our test cases. Now I'm going to submit it. Wonderful. Final thing to discuss is the time complexity and space complexity. So our time complexity is going to be big O of the length of the longer input string n or m, where n is the length of string A and m is the length of string B. In the worst case, the loop will iterate through the longer of the two input strings or continue looping until the carry becomes 0. Our space complexity is the exact same, O of the length of the longer input string n or m, and the length of the result string can be at most the length of the longer input string plus 1, considering the possibility of a carry in leftmost position. Before I wrap up this video, I just wanted to touch on the carry variable one more time. I understand that the math.floor and dividing the sum by 2 isn't exactly intuitive, so I wanted to make it a bit more clear or come up with a different way of finding the carry. I'm going to go through the exact same process, but this time I'm going to be using the number 7, and that's the binary representation of that. I have that set up here where I'm just taking the binary sum of 7 and 7. First thing I want to touch on is the list of possible sums. Since we're only dealing with zeros and ones in this binary, the only possible results of this addition we can have is 0, 1, 2, or 3. Because if those are the only possibilities that are going to arise of summing zeros and ones 3 times. These aren't an exhaustive list of all the possible configurations in which you could, but it is one of the possibilities. So the first 2 numbers are representing the digits from string A and string B, and the number in green is representing the carry. Cool. Also, this table here is representing these decimal numbers, so these sums, 0, 1, 2, and 3, in binary format. Now that we have that context, let's get started with this. So 0, that's the carryover. 0 plus 1 plus 1 is 2. 2 in binary is 1 and 0. We read everything from right to left in binary, so we'll put the 0 down in place of this column, and then in the next column, that 1, that's going to be the carry. So we'll take that to the next column and put it up there. 1 is the new carry. Now we're going to do 1 plus 1 plus 1. That's 3. 3 represented in binary is 1 and 1. We'll put this 1's place down here, and then reading from right to left, the next column is the 2's column. That 1 is going to be the carryover. And we'll throw that up there. We have the exact same thing again, so 1 plus 1 plus 1 is 3. Same situation, we'll put the first one here, and then the 1 from the 2's column, going to be the carryover. And now we're in the last column, and we have no more numbers for A or B, so we'll just assign those the number 0. We'll take the sum of 1 plus 0 plus 0, that's 1, as you can see, and that's our final answer. So if I just do the sum of this real quick, it should be 14, and I'll just confirm that for you. That's 1, 2, 4, and 8. 8 plus 4 plus 2 is 14, so we're all good. Okay, so if we take a deeper look at this table, we can come up with the conclusion for our carry variable. If the sum is 0 or 1, there is no carry. We'll just use this number directly, the 0 or 1, in place of the sum for that digit. If, however, the sum is 2 or 3, then we're going to have more than one number and we'll have to have a carryover. And in both of those cases, it's going to be 1. So if I just translate that to an if statement, if the sum is equal to 0 or if the sum is equal to 1, then our carry is going to be 0, as we can see here. Otherwise, if the sum is equal to 2 or if the sum is equal to 3, then we're going to have a carry of 1. I hope that provides a bit more clarity. Here's the code for what I just discussed on the whiteboard with calculating carry using the if statement. I've commented out the old way of calculating carry right here, and you can see that there's no difference in the code other than this if statement. So I'm just going to directly submit this, and it passes all the test cases for LeetCode, and it's a completely valid way. So if this is more intuitive and clear to you than the math.floor and dividing the sum by 2, then more power to you.